This is section 8.2, part A, vectors in the coordinate plane. Your I can statements, I can represent and operate with vectors in the coordinate plane, and I can write a vector as a linear combination of unit vectors. So component form is a vector represented by its rectangular components. Its initial point is that the vector is at point A, x1, y1, and the terminal point is at point B, x2, y2. Then the component form is just going to be x2 minus x1 and y2 minus y1. So if we need to find the component form of this vector, your first point is your x1 and your y1. The second point is your x2 and your y2. So we're just going to do 3 minus negative 4 and negative 5 minus 2. So our component form is going to be 7 and negative 7. To find the magnitude, you can do the distance formula with your original points, or if it's already written in component form, the magnitude is just the square root of a squared plus b squared. So since we've already found the component form for points A and B, it was 7 and negative 7. To find the magnitude of this vector, we just do the square root of a squared plus b squared. Or we're going to do the square root of 7 plus negative 7. 7 squared gives us 49. Negative 7 squared is also 49. So the magnitude of vector AB is radical 98. Our vector operations tell us you're allowed to add vectors, subtract vectors, and you can multiply by a scalar. When you're adding vectors, you just add the x components and add the y components. When you're subtracting, you subtract the x's and subtract the y's. And when you multiply by a scalar, you just distribute it to both values. So right now we have vector w plus vector y. To do this, you're going to add your x values, then you add your y values. Negative 4 plus 2 is negative 2. 1 plus 5 gives us 6. On the next one, we have vector x minus 2 times vector y. So the first thing we need to do is distribute that 2. If we distribute the negative 2, then this is going to be negative 4 and negative 10. Now if we add the components that are in the same location, negative 1 plus negative 3 plus negative 4 gives me negative 7. 0 plus negative 10 is negative 10. Now a unit vector is a vector that has the same direction as your initial vector, but it has a magnitude of 1. So it's still going to be facing the same direction. It's going to start at the origin, and it's going to have a length of 1 unit. It is sometimes useful to describe a non-zero vector v as a scalar multiple of a unit vector u with the same direction as v. To find u, we're going to divide v by the magnitude of v. So to find our unit vector, we're going to do 1 over the magnitude of v, and then we're going to multiply it by the vector itself. So the first thing we need to do is we need to find the magnitude of our vector. Remember, that's a squared plus b squared. Negative 2 squared is 4. 3 squared is 9. So the magnitude is radical 13. So to find the unit vector, we just take 1 over the magnitude and then multiply it by the vector itself. This just means we're going to distribute that to each piece. So this is going to be negative 2 over radical 13 and 3 over radical 13. But if you remember with radicals, you are not allowed to leave the radical in the denominator. So we can move the radical to the top, leave the number in the bottom. So this is a unit vector that is going in the same direction as vector v, so it has the same angle measure, but it just has a length of 1. So this tells you where it would stop if it started at the origin, had a length of 1, and was in the same direction or the same angle as the original.